All right, so in part 1.5, we just got through talking about panel data in wide format and some of the extra capabilities it gives us. So this is in exercise 1.5, we're going to actually go through and work with this data set directly. So what we're going to do is construct nice scatter plots to show changes through time. So we're going to make little figures that look like this. We're going to use 2 different years, and we're going to use a scatter plot to make to visualize the changes in coffee consumption per capita. All right, so this is some of the code in the slides if you like. I'm going to hop on over to exercise 1.5, click on the notebook, which loads the notebook in the browser. And then, as always, I'm going to save a copy so I'm not working directly in an unsaved version of my browser. All right, so I'm just going to run the first cell. We have our imports, importing pandas, matplotlib, and then Seaborn, our main visualization tool. And then I'm giving you a file path to the data set on my website. All right, so I'm just going to load the data set. Here I have the per capita. And you can see this is panel because we have one country showing up with many observations. So many observations through time. You can also see this is wide format because instead of representing a country at a particular time in a row, we're representing one country in the row at many points in time across different columns. All right, so the first thing we want to do is to compare between years. And we're going to construct a scatter plot to do this. So all I'm going to do for a scatter plot, as you're becoming familiar with Seaborn, this will become sort of more intuitive, is we have SNS dot scatter plot. And then all I'm going to do is give it the data set and then define what the X and the Y variables are. So here the data set is per cap, and then the X-axis, I want this to be the 1999 column, so 1999, and then the Y column is 2019, and then I'm just going to run this. All right, so here we have a scatter plot, and if you're thinking about how we would use this to track changes through time, you may be looking at this and thinking, oh, it looks like coffee consumption per capita has actually gone down. You would see the slope looks pretty flat. And we had talked about points above the 45-degree line as representing increases in coffee consumption per capita. But one of the things about this figure is that it's actually a bit misleading. Part of what's misleading about this is the vertical axis and the horizontal axis don't have the same units, so the scale is different. And so what we want to do is actually fix this problem. I want the axes to have the same limits. So we've used a lot of Seaborn, but what I'm going to do is use matplotlib, what we call PLT, to change the limits. And we can do this in 2 ways. If you're using Gemini in the browser, in the notebook, you can just ask it directly to change the limits. So you could say, make both axis limits 0 to 24. And it will interpret your English written as a code comment and turn that into Python. It's essentially a English to Python translator. And if you run that, then we get a much clearer figure. The axes are the same, and our figure is a lot nicer. The other way to do this is just to know that we can set the X and the Y limits using plt.xlim and ylim. The other thing we want to do is to create a 45-degree line. Instead of filling in the code down here, I'm just going to add a 45-degree line to our original figure. And this is one of those things, I've been writing code for over a decade, and I still generally don't remember how to write a 45-degree line. So one of the things that's very helpful in our modern world is to just ask Gemini to do this for us. So AIs are here. The way we would do it before AI is to either consult code we'd written before, or to experiment, so just to play around with a few things, or to Google. So all I'm going to say is add a 45-degree line, and that'll fill it in for us. If we run this, it'll look like this. I think it looks a little prettier if we change the line style. So I'm going to say line style is equal to this thing. And then we can see countries that have increased their coffee consumption per capita, and then those that have decreased. All right, so very nice. And then the last thing we want to do is actually go through and actually count how many countries have increased or decreased their coffee consumption per capita. So the first thing we're going to do is to construct a new column representing the change. So just like we did in time series, we can construct a new column based on existing columns. So I'm going to say I want per cap. I'm going to define changes to be the change in coffee consumption per capita between our 2 years. And then I'm going to look at the first year, our second year, per cap, 2019. And then I'm just going to subtract off the base year. So this would be 1999. So per cap and 1999. So all we're doing with this operation is going row by row and comparing the in that row the value in 2019 to the value in 1999. So we're effectively comparing this number to a second number. Okay, so if we run this, we get a new column. We can take a look at this if we want. So per cap changes. I'm just going to list out the 3 columns that we care about. And you can see what's going on. So we have the change is negative. So we have a decrease in coffee consumption per capita for this first country. And we can see this, our second year is smaller than our first year. So just to confirm that this is what's going on, we can see that changes is just the difference between these two. And then it's the difference for each one of the rows. But then we want to get a sense of how many have increased and decreased. One thing we could do is just plot the histogram of changes. So we have sns.histplot per cap x is equal to changes. And this will show us the distribution of changes in coffee consumption per capita. And you can see we have this 0 here. So anything above it is an increase. But what we want is actually just to count. So the last thing we're going to do is actually count exactly how many countries have increased their coffee consumption per capita. We're going to spend an entire section talking about filtering because it's such a commonly used tool and incredibly powerful. But I'm going to show you some of the basics here. So if I have per cap and I'm looking at the column changes, I have all these different rows. And what I want is to check whether each row is greater than 0 or less than 0. So I'm going to perform a logical check. I'm going to ask each one of these rows whether it's greater than 0. If I run this, I get a list of true and false. Now, I can take this list of true and false and put it into square brackets. And Python is going to interpret this as me wanting or not wanting particular rows. So if I put this list of true and false inside brackets and have the true and false go inside brackets like this, Python is going to look at the data set per cap and only return the rows where the condition is returned as true. So if I run this, I get the entire data set, but only the rows where there's an increase in coffee consumption per capita between these 2 years. And what we can see is we have 24 rows, which tells us that we have 24 countries that are increasing coffee consumption per capita between these 2 years. Okay, so this is really nice. These are some of the powerful things we can do with wide format panel data. Figuring out changes through time and doing this systematically for every country in our data set. So this ends part 1. We're going to turn our attention to mini exam 1, and then we'll move into thinking about bivariate exploratory data analysis in part 2. So I'll see you in the next one.